You are one of the last Neanderthals. No plague hits. No final battle comes. Just slightly fewer of your babies make it to adulthood each generation. That alone is enough to erase your whole species. A tiny drop in surviving children sounds too small to matter. It isn't. In Ice Age populations, a gap so small you would not notice it in one lifetime can still decide everything if it keeps happening for thousands of years. Extinction does not always need one giant killer you can point at. Sometimes a species just stops replacing itself fast enough. The bluntest version is almost absurdly small. Hold the exact number for a second. The point is that a tiny drop in fertility, or a tiny drop in infant survival, can break a population over a long enough time. Not because any one year is dramatic, because the losses keep adding up. Picture one band after another. One fewer surviving child here, another there, then a harsh winter hits and the group recovers less than it used to. A hunting accident kills 2 adults, and the band does not quite fill that gap again. Nothing looks like the end of a species. Then enough generations pass, and that is exactly what happened. But this only works if Neanderthals and Homo sapiens shared the same world long enough for that slow population math to matter. They did. The dates do not show one clean night when they disappeared. They show a messy map instead. Between about 41,000 and 39,000 years ago, their usual stone tool tradition, called Mousterian, fades out across Europe. The timing changes by region. Some places go earlier, western pockets last longer. In France and northern Spain, the overlap with incoming Homo sapiens lasts roughly 1,400 to 2,900 years. That long overlap matters because one sudden disaster should leave a sharper drop. But what we find instead is a patchwork. One valley empties first, another lasts longer. One region holds out while another has already changed hands. Less like a movie ending, more like a long retreat. Neanderthals also were not one giant, dense population spread neatly across Europe. Their long-term breeding population was only about 3,000 to 3,900 individuals for most of their existence. Scientists call that effective population size. The plain meaning is simple. Across all that time and land, the breeding pool was still tiny. So even when the species covers a huge map, the real picture on the ground is small bands scattered out, loosely connected, and often isolated. In groups this small, one bad winter or 2 deaths can push a band into collapse. A local group loses too many adults, the sex balance goes wrong, a few children do not survive, and the nearest band is too far away to easily trade mates with. Inbreeding rises, recovery slows. Then another random hit lands. Low numbers make everything harder. Finding mates gets harder, sharing food gets harder, and recovering after deaths gets harder. Once the bands get thin enough, each loss makes the next one more dangerous. You can picture it like trying to keep a fire alive with almost no coals left. One coal lost is not the whole problem. Each missing coal makes the next loss worse. Then Homo sapiens arrive with a different advantage that barely looks like an advantage at all. They have a bigger source population. Even if the 2 species were identical in raw ability, a larger, connected source population keeps winning dull, strange contests. Local bands disappear sometimes because of weather, accidents, lean years, bad births, or bad luck. But the empty patch does not stay empty. It gets filled again. If one lineage has more people feeding into that larger population, it fills more of those gaps. A larger incoming population can replace local losses without conquest. If modern humans kept entering Europe from a much larger source population, every local Neanderthal disappearance created another chance for sapiens to fill that space. Repeat that long enough, and the older lineage gets pushed out by ordinary repopulation. Here is where it gets weirder. Even models with no special fitness advantage still push toward replacement if the incoming population is larger and better connected. Modern human numbers in Western Europe also seem to jump by roughly tenfold during the replacement window. A bigger network loses people too. It just has more people to send back. Now put the two things together. One species is already spread thin and easy to break. The other keeps arriving from a larger source population. Then add even a tiny edge in births, infant survival, or recovery after losses. A larger source population plus a tiny fertility edge is enough. You wouldn't notice a grand turning point in one generation. You would just see fewer neighboring bands than your grandparents knew, fewer exchanges, and longer gaps between visits. A winter that used to hurt but not break you now breaks you. A child who might have survived in a slightly larger, healthier network does not. Or put less politely, the real killer may have been recovery.
Not which species won one fight, but which one could keep replacing its losses while the others slowly stopped being able to. Here's the anchor case, and it is brutal. If young Neanderthal women had a fertility shortfall of less than 4% sustained over time, that could wipe out the whole population in about 10,000 years. That time window lands almost right on top of the archaeological timeline people argue about. A 5% drop in infant survival can break it even faster. That is why the tiny edge matters so much. Neanderthals had already survived savage climate swings for more than 200,000 years. But once populations get this small, random swings in births and deaths matter more. Inbreeding matters more. Failing to find mates matters more. A species can survive Europe for hundreds of thousands of years and still lose to repeated small losses. Brutal. Also very rude of math. There is another wrinkle, and this part is easy to miss. Neanderthals did not vanish without leaving any trace. Most people outside Africa still carry a small amount of Neanderthal DNA right now. So disappearance did not have to mean everybody died. Some were absorbed into Homo sapiens while the separate Neanderthal population kept shrinking. The honest answer is that nobody can point to the exact cause with total confidence. There's no fossil record that gives you a clean measure of Neanderthal fertility or infant mortality. Climate swings may have pushed the decline harder, disease may have mattered, violence may have mattered, mixing with Homo sapiens may have mattered. All of those could have sped things up, but the slow population version fits the shape of the story unusually well. The dates are staggered, not clean. The overlap lasts centuries to millennia. The populations were small. Replacement can happen band by band and valley by valley, without one final catastrophe that anybody at the time would have noticed. So, when you ask how every other human species disappeared, the answer may be colder than a final battle. Not one clean ending, not one monstrous blow, not one night when humanity almost ended. Just a few more surviving children here, a few more bands recovering there, repeated until only one lineage was left. That is the part that stays with you. That is the part that changes the whole story. That is why another kind of human can disappear without anybody seeing an ending at all.